Okay, so we will start. Okay, so here we have started our discussion from hydrostatic forces, and that we have not completed. Okay, so we will try to see this particular problem, and let's see how we can work out with this one, with this example. So now all of you please try to solve this question. So here, my dear friend, yeah. So anyone getting any answers? So we will try to think of this plate, you know, try understanding. So here, what you're understanding, there is a barrier which can be seen from the figure. That if I show the barrier, this is the barrier. This barrier having the unit width. This particular width they have given as 1 unit, right? And they mention that it is a perpendicular to the plane of screen, right? And it is modeled as a cantilever beam, right? Because it is fixed at one end and the other ends are free. But here on one side we have the water, on the other side also we have the water, but of different heights. Here, if you draw the pressure distribution diagram, so if I neglect the atmospheric pressure variations, right, or because as atmospheric pressure will be acting on both the sides, so if I just draw, so there will be linear variations as density of the water will be constant, so there will be some linear variations. And if I draw it, so it will be something like this. On to the other side, when you see that the variation will be like this. So this is the pressure distributions diagram, right? linear variation, we know that pressure is what? Rho gh. Pressure will be directly proportional to h. For being density and g will be constant, so pressure will be directly proportional to h to the power 1, just like a y is equal to directly proportional to x. So we used to draw like this, but here the variations are in an inverse manner. That means from a hydrostatic law we know that the pressure is decreasing in the vertical upward direction and increasing in the downward directions, right? What is the absolute maximum bending moment developed in the cantilever beam, they are asking. So this is the hydrostatic pressure, this is the barrier which you are looking right now. This is the barrier which you are looking right now, the blue color one. And there is some pressure variations which are happening. What is the centroid or center of pressure for this pressure variations? Anyone can tell me? What is the hydrostatic force due to these variations? First of all, tell me that one. What is the hydrostatic force? F1. F1 will be rho 1 into rho g into h bar into area 1. Area 1. So 1000 into 10. H bar will be what? The total height is what? 4 meter from here to here. And the center of gravity will be here. It is at a distance, as the free surface is coinciding with the edge or the top surface, so we'll be having 2 meter. 2 meter. And area will be what? 4 into 1. 4 into 1. Because width is what? Width is 1 unit, right? So what we can just calculate from here, that it is 80 kilonewton, right? This 80 kilonewton, my dear friend, will be acting at a distance. Center of pressure will be what? In this case, what is my h bar cp? What is my h bar cp, my dear friend? If the total height is 4 meter, what is my h bar cp? H bar cp, we know that h bar plus igx sine square theta divided by area into h bar. But in this case, do you really need that formula? As the top surface is being coinciding with the free surface, you will not be required that much of calculation, because for a uniformly varying load, what is my center of gravity of a uniformly varying load? Not the geometry. Center of gravity of a uniformly varying load will be what? Center of gravity of the uniformly varying load will be 2h by 3 if the total height is h. So from the apex it is 2h by 3, from the bottom it is h by 3. Again, if anyone confused in that, how we are getting 2h by 3, sir, can you please explain, as it is coinciding with the free surface? Let me explain that. H bar is what? H by 2. From here we are getting what? H by 2, right? See, those who are having confusion, sir, my basics are not clear, please mention in the classroom chat section. Otherwise, how can I understand whether this 2h by 3, some basics, these things are not, right? So please, whenever you have any doubt, any students, right, try to mention that, sir, I don't have this basic understanding, please explain that, I will explain, right? Now igx, what about the moment of inertia? The moment of inertia, if I draw the side view of that, this is my h, this is my width 1 unit, and moment of inertia about the centroidal x-axis I have to take. The centroidal x-axis I have to take, that is a perpendicular to the cross section, which is the axis which is perpendicular, which is coming out of the laptop screen. So what is that center of moment of inertia about that axis? That is 1 into h cube by 12, because we know that bdq by 12, that is a formula where width is what? D, and b is nothing but what? 1 unit. Area will be what? H into 1, h by 2. Sine theta is what? Theta will be 90 degrees, so sine 90 will be 1, sine 90 square will be 1. So when you do that, h by 2 plus h by 6, so you will be getting 2h by 3. As the top surface is being coinciding, but this, suppose that my surface is somewhere here and having the height h from a distance x, and if I want to calculate that where exactly from a free surface my force 1 is acting, so don't write, sir, it is 2h by 3 plus x. This will be wrong. Getting my point? this h bar cp will not be same exactly as what you have done your calculations. Don't try to write like this, right? Because what about first of all h bar? H bar will be from here to here, this is h by 2 plus x. Accordingly h bar cp will also be there, that is h bar plus igx divided by area into h bar. When the top surface is not coinciding with the free surface, but in this our case it is being coinciding, so we can directly write it. Otherwise if you have any confusion, so you can derive from here h bar cp formula. Is that clear? Any doubt till this point? Tell me guys. These are not the very high class problem, very high level some rocket science problem. Don't think like that. Whenever I used to take the problem, I try to build some basic concept in that from a very, see, I have taken the small section, means first I have taken the left side water, right? Then I will be taking what? Right side water. Then I will be calculating the movement of the forces, right? Now, which part you have not understood? Specifically, if you can mention that. IGX, please remember that moment of inertia about the centroidal x-axis. Whatever the x-axis is there, which is being passing perpendicular to the plane of the board, right? So, see the barrier which has been. So that's why, please, guys, in my especially in my classes, please try to join the class on time. The barrier, as shown in the figure, which is being subjected to two-side water, right? And taking the density of the water, acceleration due to gravity, they are asking what is the maximum bending moment. You think like this barrier as a cantilever one. You just think this barrier as the cantilever being, right? So whenever we are thinking this like a cantilever beam which is being fixed like this and which is being subjected to force F1, force F2, right? And simply we have to take the moments about that, which point? About O point, for example. And that is what they have mentioned in the problem. Now, from starting building one, from the left side water, if I take of the barrier, then I will be having the pressure variations, uniformly varying load, right? This is my pressure variations. No, that is not correct. You're talking about the absolute bending moment, right? So this is my total pressure variations. This is my total pressure variations. And in this pressure variations, this will be uniformly varying load. And you know that from a uniformly varying load, which is being coinciding with the top, whatever the top edge is there of the plate, a barrier is coinciding with the free surface. So directly I can take center of pressure from a top surface as 2h by 3. If 2h by 3, how we are getting confusion? You can check it from here, h bar cp, which is nothing but h bar plus igx sine square theta divided by a into h bar. H bar is what? We have h by 2. Igx is what? Moment of inertia about the centroidal x-axis. Moment of inertia about the centroidal x-axis, my dear friend. Right? Divided by area into h bar. Igx is what? 1. See, whenever, if I just show you, just wait. See, when you look at from here, this one, the rectangular which is having some dimensions a and b. What is the moment of inertia? Ixx. Ixx. A, that is the width. B, that is the height. B cube by 12. Same formula. Yes, that is correct. So same formula I am going to take here, where my width is nothing but 1 unit. Width is nothing but 1 unit. Now, how we are getting the width, sir? You try to imagine this, side view of that. The side view may look like this, right? This is my side view. If I tilt it, this will be my side view, right? So here, what will be the answer for that? 1, that is the width, that is given as 1 unit. HQ divided by 12, area will be h into 1, height, h bar will be h by 2. Why h by 2? Because we know that the center of gravity of the plate from here to here, this will be h by 2. But whatever the height which is being there, which is being surrounded by the water, so from here to here, this will be my h by 2, which is 4 by 2, which is 2 meter. So we are not bothering about the height which is not being surrounded by the liquids. Right? Till this point, any confusions? Now, how to calculate F1? In the last class, we have known the formula rho g h bar into area 1. Rho is 1000, g is 10, h bar is what? 2, area is what? 4 into 1. So you will be getting what? 80 kilonewton. Check it out. What about force F2? What about force F2? Once again, I am requesting you guys, please, whenever any basic understanding you are not getting, let me know. Because I can never come to know whether your basics are clear or not. Right? Because I'm assuming that engineering mechanics has been done perfectly for you and you have finished engineering mechanics before coming to my classes. Center of gravity, centroid, moment of inertia, that formula, that should be known, right? Otherwise, if I keep on repeating those things, engineering mechanics thing in the class, otherwise totally it will taking what? Too much of time. Too much of time it will be taking. If you want, sir, you derive center of gravity of the rectangle, you please derive the centroid, you please derive this IGX formula, then what you have done in the engineering mechanics? That is my next question. So please try to understand. If the basics are not clear, sir, you please explain the derivation of IGX. I will be explaining, but let me know that. Right now. So here, what will be my F2 force? F2 force will be what? F2 force will be what? F2 will be rho g h bar into area 2. Area 2, because the plate, only this much of width will be surrounded by the second water. Right? So what we can write 1000 into 10 into h bar. H bar once again will be what? If I just write in the next page, that is a better one. This is my barrier and this is my force of water which is being there at a height of 1 meter. So my F2 will be, which is being there at a distance from a free surface at a distance uh, 2 by 3, because we know that formula 2h by 3 where h is what? 1, right? So from the bottom it is 1 by 3. So Ft will be rho g h bar a2. So rho is what? 1000. 9, sorry, it is given as 10. Area will be what? 1 into 1. A2 will be, sorry, that is what area. H bar will be from centroid, which is the part of the plate which is being surrounded by the liquid. That is the height we have to take. Don't take the full height centroid of that. No. So 1 by 2. So when you calculate, you will be getting what? 5 kilonewton. So my dear friend, now we have to take the moment. This is a barrier where force F1 is being acting at a distance, what we say, 2h by 3, where h is nothing but 4. So 2 into, sorry, 2 into 4, that is 3. So that will be 8 by 3. And so from the bottom, it is what? 4 minus 8 by 3. As the total height of the water being surrounded here is what? 4 meter. And what about the next segment? F2 will be 5 kilonewton, which is being there at a distance 1 by 3. So now take the moment about this point. Summation of moment about this point will be, you can take this moment as clockwise and this anti-clockwise moment to be as negative, because it is doesn't matter. They mention absolute value. That means we have to take the mod of that. So when you just calculate, F1 is what? 80 into 4 minus 8 by 3 minus 5 into 1 by 3. So when you calculate, what you are getting? 105 kilonewton meter will be the answer. Getting my point, all of you? because they have mentioned that, some of you might be taking, sir, clockwise I will take negative, anti-clockwise, sir, I will take positive. Yes, you can take, but we have to calculate the mod absolute value. We do not think about the, we no need to think about the negative sign of the answer. Upper end, I don't understand from here. No, bottom one we have to see. Check the data. The bending moment developed in the cantilever beam. Maximum will be what? Always remember, maximum bending moment will be there at the fixed end in a cantilever beam, right? Whenever you have any load. So always remember that the fixed support will be subjected to maximum moment, because see, what is the bending moment equation? At a cross section XX, P into X, right? This P into X, as it keep on varying X from 0 to L, my bending moment will be start varying, and it is gonna maximum at the what? It is gonna maximum at the fixed end. So this is my bending moment diagram. Getting my point? Now is it done? Can I move to the next one? That's why, guys, I am basically, if you think the timing of the question, time per question I'm taking too much, you know even though these are the very straightforward question, but I'm taking time so that you can understand, right? See here, which part you are saying? See, 1 by 3, the right side water, whatever the water is there to this right side, there, that is not there for the full height 4 meter, that is there only for 1 meter. Then what about f2 value from the top, from a free surface at a distance? Once again, that is 2h by 3. You consider this as height h2. So that will be from here to here, that is 2h2 by 3. 2h2. H2 is what? 1. So it is 2 1 by 3. That is 2 by 3. And what about from the bottom? It is 1 by 3. And that is what we have to take the moment. Getting my point? See, some of you might be thinking, sir, yeah, I got your doubt. See, some of you, what you're thinking, sir, barrier is there, the force 1 is there, force F2 is there, and they have some larger distance from the top. If you're calculating the maximum bending moment here at the point B, for example, what you will do with the calculation of bending moment calculation, because there is a nobody is there to resist that moment, but here somebody is there. If they will apply that much of force, the beam will say, hello, you go back. Suppose they are applying the net bending moment of 105 in the clockwise directions, what the support will say, hello, you go back. On the top, who will say that? Nobody is there. Getting my point? So these are the support types of support, whether it has been discussed or not in engineering mechanics. Pin support, roller support, equilibrium conditions. Tell me, guys. You cannot completely ignore engineering mechanics or whatever the subject which is being finished. You cannot think that it is being finished, let me throw that. No. All the subjects are interconnected. And if you want, sir, I will just please continue engineering mechanics, then I need to skip some of the topics to finish the course within the time period. And that is a very much, frankly, I'm speaking to you. So you need to revise before coming to my classes your mathematics, your engineering mechanics, right? Whenever it is required, I'm explaining you. But don't think that ever that, sir, this is not the basic problem, this is a very high-fi problem. It is not at all. You think that, you just think like a two problem. One here and second is here. And it is being clubbed together. And engineering mechanics has been tested over here. The types of support where the bending moment will be maximum. That's it. Even you can see the timing, 20 minutes almost. I have taken 20 to 25 minutes of the time, right? Nobody gonna take that much of time, believe me. 2 minutes finished, 3 minutes finished, that's it. Now, is it done for all of you? So please try to revise engineering mechanics as maximum as possible. You have to struggle at the initial phases. You have to struggle with every problem. Believe me, everything will not be served you on the basically what plate and directly you will be eaten. No, that is not going to possible. You have to work hard. That is for sure, right? Even though you are learning from IT professor, also directly he will be telling you high-fi things only. But you need to have the basic understanding of that, sir. What the IT professor they are telling to you, right? So please try to go through engineering mechanics. That is complete, because some of you who are having doubts in that, on the top, on the bottom, on the middle, so where it will be maximum, definitely you have not clear engineering mechanics, right? Please make sure that your engineering mechanics is very much clear, because in the strength of material also, again these things will be creating some panic situation, right? Now, so we have been discussing about the problem, this particular problem which I have given, those who are not able to get, definitely they have the problem in engineering mechanics. The free body diagram on the slide, basically on an inclined plane. That's completely based on the engineering mechanics. And where the fluid mechanics has been involved, let me tell you. This body, if you just make the free body diagram, right? So whatever the weight is there, let's say this is a weight, this is theta. This is W sine theta. This will be W cos theta, right? Now you try to understand who will be basically opposing the sliding down motion of the particular block. The viscous force, whatever the fluid is there, the fluid will say, the fluid will offer some kind of resistance on this one, something like this. That is a viscous force. In engineering mechanics you have the friction force, right? But here they have the viscous force. And how the viscous force will be varying according to Newton's law of viscosity into area. As the gap is very, very small, you can assume the linear profile of that area on which it is acting. You just try to equate summation of forces in the direction of motion has to be equated, right? That is what they have mentioned, right? Determine the force F. Now here the force F is also acting. The force F is also acting. That also need to be resolved in this one, in these directions, right? So if you just resolve something like this, so what is going to be there? So this is theta. So this will be my P. What about this one? This will be my P cos theta, and this will be my P sin theta. So once again, here we have P cos theta. Here we have P sin theta. Summation of forces in this direction. You assume this direction to be, let's say, x dash. So summation of forces in x dash direction to be mass into acceleration. As the it is moving with the constant velocity, so mass into what? dv by dt. So definitely this has to be zero, right? So whatever the role which is being played by friction in the engineering mechanics, that is being played by the viscous force. That's it. That's it. Apart from it, you need to know everything about the engineering mechanics, right? So here W sine theta minus P cos theta minus viscous force, that is mu into V by H into area, that has to equal to zero. That's it. From here you will be getting the force P or whatever the F is there, right? Getting my point or not, all of you? So whenever you have doubt, you just go through the previous subject which is being completed, right? Definitely I will give the solution. Those who are having the doubt, I will provide the solution of these things, but you have to work hard. Why I have just given this problem as a homework? So that you learn some fundamental of what you call, how the viscous forces will be acting. Definitely you know that this will be trying to oppose the motion of the body, right? So the fluid will offer some kind of resistive force here, and onto the plane, onto the inclined plane, this will be something like this. This thing. Remaining thing I have given as a homework, so that you revise your engineering mechanics on how to resolve the forces, if the basically forces are acting on an inclined plane. Getting my point? Tell me, guys.
Sir, why there is rho cos theta?
What? Which one? Yeah, here, yeah, you have to be little bit. See what they have mentioned. Direction of velocity. You have to very carefully observe. Tell me the direction of the viscous force. That is opposite or what? The block is moving in this direction. See that the direction of motion is what? In this direction. So definitely viscous forces will be acting onto the plate, onto the block in these directions, and onto the plane like this. So one mistake that is gone. So here you have to reverse your directions like this. You only think the answer will be completely changed, if you just do the mistake. So that's a very good problem actually. Getting my point, all of you. So always you have to see the direction of motion. Where exactly the block is moving in the upward directions. So friction force or the viscous force has to oppose it, right? Getting my point, all of you. So that the constant velocity of the block can be maintained. Now, is it done, all of you? Can I move to the next segment? All of you have noted down? Because before fluid kinematics and fluid dynamics, fluid statics, a little bit, you require some fundamental of basics, and few questions of fluid properties will be required fundamental of engineering mechanics. Please note down quickly. Now, so here, yeah, when you see this particular problem, again, this is one of the very good problem. Anyone has tried this one? A hinged which is being there, right? So here, when you try to understand this particular problem, so now try to understand this. Here, so what is the direction of hydrostatic forces? That is the very first thing. Will it be like this? The resultant hydrostatic force? That is very much clear, all of you. Check it out. This will be acting exactly where? This will be acting exactly where? H bar Cp. H bar Cp. Now I am taking a different case. Vertical, we have already covered, right? Now let me take the inclined case, right? Inclined case. Now it is being inclined at a 30-degree from the horizontal. From a horizontal, and I mentioned that what is the theta value? 30-degree, because it is being given from a horizontal direction. If you just go through the notations, right, the plate which is making an angle 30-degree with the horizontal, so that is my theta value. Check it out. Getting my point? So very big thing is that we have to calculate very first of all what the minimum mass of the gate in kg per unit width, right? The width of this particular gate has been given as what? 1 unit. Now you try to understand the basic fundamental of this problem. What is happening? Weight of the gate will be acting like this. What the weight will try to do? What the weight will try to do? Because whatever the hydrostatic force is there, that will create the movement about this particular point, and that will try to rotate it. Once it will try to rotate, it will try to open the gate. It will try to open the gate. See that? The plate might be open like this after a certain point of time when the force will be acting, when sufficient mass is not there. But what the mass of the gate is doing, it is trying to keeping the plate in a closed position. See that? You check the movement about that. It is creating the movement, this particular component. What about the movement which is being created? Let's say this is x. So this weight into x is creating the movement in the clockwise directions, and that is what keeping the gate in a closed positions. Otherwise all the water will come out, from the dam, and so much of damage will happen. So to avoid that, what they are doing, we are keeping sufficient amount of mass, right, or the weight per unit width, so that the gate will be always in a closed positions. So now what we have to determine, we have to determine the mass. So definitely, what the basic fundamental, this is a rod, this is the mass into g, and this is my hydrostatic force. Remember, hydrostatic force will always be perpendicular. If it is a vertical, it is like this. If it is an incline, it is like this. If it is a horizontal, perpendicular to like this. Perpendicular to the surface area of the plate. Always perpendicular. Do not apply the force like this. That can also be tested in gate exam as a free body diagram, because in aerospace they will not give that much of tough problem. So what they will give, they will just give, they will check your fundamental whether you know that thing or not, and they will put in the options like this free body diagram, something like this, mass g, resultant force, something like this. Who knows that, right? So please try, always remember that whether I'm solving mechanical problem or any branch problem, you try to note down in your notebook, right? Now, so here, so this is what we have done the calculations, and what is the hydros resultant force formula? That will not change. That will not change based on the orientation has been changed from vertical to angle theta. No, again from here also, rho g into h bar into area, right? So when you try to calculate from here, what is my rho? That is 1000. G is what? If you just check it out, 9.81. H bar. What is my h bar? That is a big question. What is my h bar, guys? See, this is my plate. Plate centroid to the top will be what? 2.5. Right. But always remember, my dear friend, the whether h bar cp or h bar, that is a vertical distance. That is my vertical distance, right? So that is my vertical distance, h bar. So how to calculate from here to here? This h bar, this is my 30 degree. This will also be my 30 degree. So sine theta will be, sine 30 degree will be h bar divided by 2.5. So once you calculate h bar from here, that is 1.25 meter. So try to remember the basic things which I'm telling you. H bar, vertical. Note down in your notebook. Like in a wording, you please note down h bar, that is a vertical, right? Because you might have done a little bit of this portion in your BTech also, right? I'm agree with the fact. So what you have to do, right? If you're thinking, sir, before I have not done, I need to struggle very, very hard for this particular topic. Yes, you have to do that. You have to do that. That is the benefit of basically what? Taking admission in the Feb batch, so that you have ample amount of time to doing the practice and all, right? So what we can do? So what we can do here, 1.25. And what about the area which is being surrounded by the water? What about the area? This is the area. Perpendicular, if we draw the horizontal view of that, so width is what? 1 unit, and total inclined height will be what? 5 meter. So 5 into 1. So if you just calculate resultant hydrostatic force, tell me the value. Tell me the value, guys. Resultant hydrostatic force, 61312. 61312.5 Newton. right? That is what my resultant force. If I take the whatever the width as 1 unit, this is my resultant force, right? Please understand each and everything, right? Now, this is my resultant force. Now, resultant force from where to where it will be acting? It will be acting at a distance h bar cp, right? Don't think, sir, h bar cp will be like this. No, that is wrong. H bar cp we have to write something like this. Getting my point? So please make sure that h bar cp will be vertical distance from a free surface of the point of action of load, right? So h bar cp, where exactly the this is a portion, or this is a center where exactly the hydrostatic forces will be acting on a plate. H bar is nothing but my dear friend, that is a centroidal distance, vertical centroidal distance of a plate from a free surface. The vertical centroidal distance. Remember, vertical centroidal distance. Getting my point? Now, so what is the next thing you can do? You have calculated the resultant force, weight, mass. That is what being we have to calculate. G value, 9.81. H bar Cp is a big task. How to calculate H bar Cp? How to calculate H bar Cp? H bar Cp, we know that H bar plus Igx sine square theta divided by area into H bar. So from here, how we can calculate? Let me calculate. H bar we know 1.25. Igx. Igx, that is if you just take the side view of top view of that plate. So my different, once again, that is Ixx. Width is what, 1 unit, and height is what, 5 meter. So what is my Igx? 1 into 5 q by 12, right? That is what H bar in hydrostatic forces. H bar Cp is a location. Getting my point? So at Igx will be what? 5q divided by 12 sine square 30 degree divided by area. Area will be 5 into 1 h bar into 1.25. So from here h bar Cp will be, what is that? 1.667. बाद में h bar Cp will be 1.667. Take it out. So this is my vertical height, 1.667, right? Now, if you just take the movement about the point number O, this is my consideration of hinge point O. So what I will be taking, this is a point O, 61312 Newton, and this is acting at a distance 1.667 meter. This is the mass mg. At what distance this will be acting? Mg into x. This will be 30 degree, and this is my 2.5 meter. So what about x? In this triangle, if we just calculate 2.5 meter, this will be 30 degree, this will be x. So cos 30 degree will be something like this. So x will be 2.5 into cos 30. So if you do that, 2.165 meter you will be getting, right? And what about this particular distance, my different? Because moment we have to take it, right, of the hydrostatic forces. Let's say this is a y. So from a triangle, we can calculate this is a y, this is 1.667, and my this particular distance will be 30 degree. And then what we can write? Sine 30 degree will be 1.667 divided by y. So y will be 3.334. So what we can write? Summation of moment about O to be 0. Why we are keeping it to be 0? Because hinge cannot support any movement, any external movement. So it will not offer any amount of reaction movement also. So this Fr into y will create the movement in these directions, right? So what we are writing, Fr into y will create anti-clockwise movement. This mg into perpendicular distance will be what? X will create the movement in the clockwise directions minus mg into x, that is being 0. Fr is what? 61312.5. Y is what? 3.334. That is equal to m 9.81. X is what? 2.165. So when you calculate, now tell me the mass value. So when you calculate the mass, that is 9624.7 kg, you will be getting the answer, approximate answer. So when you see that approximate answer, that is D. Movement. Some of you might be having doubt also. Sir, FR is acting like this. So movement should be FR into 1.67. Why you are taking perpendicular distance? Movement always will be force into perpendicular distance. Right? So if the force is like this, we have to take the perpendicular distance. Right? Please understand these basic fundamentals. Yeah, whatever the answers you are getting, when you see the options, so you will be getting approximate close answer to as D. Vertical centroidal distance of a plate. Vertical centroidal distance of a plate from a free surface. As a free surface is being coinciding with the hinge point, so I have taken the point to be as what? See, this is the free surface, right? The vertical h bar cp, that is also vertical.
Sir,
Yeah.
sir, for the hydrostatic force, we are putting like rho g h bar into A. So h bar
Hmm.
should be the point where the center of pressure is going to be active.
No, no, I think you have not attended the last class.
Sir, I attended a confusion in that one. Sir, I was reading
See,
numbers.
FR is we have written the rho g h bar into area, right? We never wrote the
Yes,
formula
sir.
rho g h bar cp into area. Why h bar cp will come?
Confusion is that like pressure into area. Pressure should be act on the center of pressure point only. Na? It should not be act on the center of gravity positions.
Yeah, your doubt is clear, but your doubt is there. But let me prove that why rho g h bar is rho g h bar is coming, not h bar cp is coming, right?
Yes, sir.
Yes. So, so for that, let me take the some derivations. Just wait. Hydrostatic force. So I'm taking a very general case of being inclined one, right? A very general case that is being inclined. So I will be taking that case, and let me just prove it. Yeah. So here, just wait. So let's say this is my, yeah, my free surface and my vertical plate. 2D. I'm just drawing the 2D part. 3D part, something like this, where width is W and height is H. So here, what you can just have the pressure force. You know that the variations will be something like this. So what I'm taking the small width If I draw the side view, definitely when you look it from here, this is my front view, this is my side view. So I'm drawing side view with the B, with the W, and height is as H. I'm taking a small uh, width. I'm taking one small width, a small strip of area, what you say dy, and width as W, for example, right? And this I'm taking a strip at a distance y from a free surface, for example. Any doubt? Y from a free surface,
No, sir.
right? Now what we are doing here, we are trying to writing the pressure force, right? Because pressure force into area will give me what? Pressure into area will give me the force. So what I'm just writing, the resultant force, that is my df. That means on a small elemental area, if I calculate my df force and if I integrate, I will be getting total force, right? And what is the area on this? P into dA. Can I write that? What is the pressure? Pressure at this point will be from a hydrostatic law, that is rho gy. Getting my point? Suppose water is there till here. So what is the pressure value from this point? Rho gy. There is a no doubt at all, right? So what we can write? Rho gy into dA. Getting my point? So here what we can write? Rho g y into dA. Can we write that? As rho is incompressible, I am taking it as constant. So can I write like that? If I take outside of the integral, so can I say this one? That is my resultant force. Check it out. And in from engineering mechanics, you know what we know, that y bar center of gravity formula, y into dA, or centroid formula, we know that something like this. So y bar into A, that is my what? Y into dA. So can I, and what is the y bar? Centroid of a particular plate. Getting my point? So what we can write? F bar, rho g into this y bar into area. Y bar you write or H bar you say, both are same thing. Check it out. Right? Is that clear? So there is a no point of denoting the H bar Cp or incorporating the H bar Cp into the formula, because that is of no use. That is not coming into the picture. See, the location and the pressure value both are having some different things, right? The location or the pressure value both are having some different things. The location will be here. The resultant force location will be H bar Cp. It doesn't mean that you multiply rho g H bar Cp into area of that. No. Getting my point? Yes. Yes. That is the location of the hydrostatic force. Because y into dA, if you try to integrate y into dA, the whole strip you try to integrate, the whole strip, from here to here, when you try to integrate, you will be getting the y bar into area. Getting my point? Y bar is nothing but the centroidal distance of that from a top surface, from a free surface. As I am taking the y from a free surface only, so my whole calculation will be from a free surface of which one? Of the centroidal one, CG. I should not say CG because CG will be for 3D body. Centroid is for 2D body. That is a planar body, because here I cannot think of a plate as my 2D body, 3D body, because thickness is very small, as you can see. When the thickness is very large, then that is become a 3D body. Then we say center of gravity. Yeah, please make a note of it. Now, once it is done, let me know. So I think we have, yeah. So note on the next concept: hydrostatic force on a curved surface. Not completed. Please make a note of it. So this is from centroid. Centroid is completed, right? Centroid, center of gravity, engineering mechanics. Yeah. Triangular plate, yes. See, in the triangular plate, yeah, we can discuss. See, this is a problem, and we can have it. Suppose this is a plate, vertical plate. Now we have the triangle like this. Which thing will change? Only h bar will change, right? And area will change. Yes or no? Getting my point? If there is a triangular portion, so only h bar and area will change. Getting my point? But remember, one more thing I'm telling you. Whatever the discussion is happening, that is for a symmetric sections, right? But when you see the very high level book like FM White, when you try to solve, and you will be getting interest in hydrostatic forces, because there is a no limit on any concept, right? When you start loving that topic, or when you start engaging yourself with the topic, definitely there is a no end of solving the numerical. So when you just try to see that, there they have mentioned some problem regarding isosceles triangle also, unsymmetric. So here, in that case, not only we have to think about what, in this case, how many things will be coming, tell me guys. Unsymmetric problem where we have something like this, in this case, my dear friend, x bar is getting 0, only we are getting the y bar. But in an unsymmetric problem, you will be getting x bar and y bar, both the things. All of you are understanding what I'm saying? Till now, whatever the problem we are discussing, rectangular plate, that is also being symmetric. Triangular one, which is being symmetric. Circular one, which is being symmetric about both the axes. So exactly, hydrostatic forces will be acting at the center of that. When you think of that, you know exactly, here we can able to find that. But in unsymmetric section, we have to find where exactly my hydrostatic force will be acting. You try to go through FM White problem. Very good problems are there. One solved example is also there based on unsymmetric. But if you have some time, otherwise, no use of that for the gate exam. If you have very much interest, then you can see. Yeah, correct. Means h bar cp we are calculating only once, right? Here only one time we are doing h bar cp, that means y bar cp, I would say. But here you need x bar cp and y bar cp, both you have to calculate, and that is a very beautiful problem, because when you involve there, that is not that easy. I'm telling you right now, not that easy. So yeah, so till now in gate examination, they have been tested for mechanical and civil symmetric problem. So there is a no chance for the aerospace in upcoming 5 years. I would say they will not gonna test the unsymmetric for aerospace directly. Before they will test for mechanical and civil, then they will test for aerospace, right? Because there is some common sense also in putting the question in your respective branch of the gate exam, right? They will not directly incorporate very tough one which cannot be solved by the civil engineer, that can be solved by aerospace engineer about the structure of fluid mechanics. That is not practically possible within 3 minutes of time. So even though that cannot be solved by any single student in the exam, so what they will think that, okay, they will have the data also for a single question, all the question they have the data, how many percentage student have attempted, 3%, 5%, 10%. They will take it as an ego one. So to avoid that, to satisfy their ego, they will not keep the question itself in exam. So we have to go through all these things before solving the questions, too tough problem from the any textbook, right? Now, is it done, all of you? Can I move to the next one? Hydrostatic forces on a curved surface. Note on the next topic. And when you are able to solve, when you know mechanics very good, so try to solve mechanics first, then you try to go through fluid mechanics problem, right? Hydrostatic forces on a curved surface. Otherwise you will waste your time. You will take one problem, whole day you will take the time, 8 hours or 10 hours. Don't do that study. Again, I'm telling you, do not do any kind of PhD work during gate exam. If you're not getting problem, try to consult with the faculty or in the group, WhatsApp group is there. If not, then leave it. If it cannot be solved by anyone, any students, then you just try to leave it. Or you try to put a star mark that you will solve after I'm having some sufficient amount of time. Maybe after revising 2, 3 subjects. Right? Now, I want to say that from the starting onwards, you should have a huge amount of pressure, right? That I need to finish this task, and on the next day, you should have the schedule in your mind that okay, I need to finish that particular topic, and definitely before going for the sleep, I will be completing this topic at any cost, right? So that much of pressure is there. You think like gate examination is very near to me, like it is coming closer. Always you think like that. You don't think, sir, I'm having huge amount of time, 7 months, 7 into 24 hours. That is never gonna possible, right? Now, again, I'm telling you, time is a very, very precious thing. That's why you always plot anything, any variable. You take it time on x-axis, you know, because it's like a very marching one. Like you cannot control on that, right? Any independent thing, any independent time is an independent that does not depend. That will not ask you whether you have time or not, right? They will not gonna ask you that particular time. So that is why independent parameter always plotted on x-axis, right? So that is also one of the reason why we plot stress on y-axis and strain on x-axis, right? When I will discuss, strain is nothing but what? Independent parameter. First, who will come? Strain will come, then stress will come. Without strain, without any deformations, material will not feel anything. There will not be any kind of stress, right? So all the independent parameter, not with the time, not with the strain, anything you take, that will be on x-axis, right? Now, there is a curved surface. Let me take here something like this. On a curved surface, you are not having only the force in the horizontal directions or in the vertical directions. When you see that, the forces will be acting like this. The resultant force will be acting something like this. Getting my point? And the side view, if I draw, the side view will be something like this. For example, this will be my side view of that. It is just like a plate on which my forces will be acting throughout the length of that, right? So if I just draw the top view of that, so what will be my top view, which is having a radius from a centroid? Let's say this radius is r. So what will my centroid? What will be my area? So can I say, when you draw the top view, when you look from here, this will be my r. Can I say this will be my length? Check it out. Any difficulty in that? No difficulty, right? When you take the r and l, that will be my, that projected area will be what? R into L, right? Check it out. That is a projected area in the vertical plane or what? When you see from here, that is the area in the vertical plane, right? So that is my vertical area AV. Getting my point? That is my vertical area. What about the horizontal planes? What about the horizontal planes? So by default, when you try to see what is my horizontal planes area, what is my horizontal plane areas? See, no. Try understanding. So when I resolve the whatever the hydrostatic forces is there, I will resolve in two way. One will be my horizontal component, one will be my vertical component, right? So whatever my horizontal component is there, I will be directly writing rho g, h bar into AB, area in the vertical plane. Area in the vertical plane. It is having exactly the same formula as we have discussed. You just think like this is nothing but a vertical plane, which is being projected area as AB. This is my horizontal force. And you just think the vertical force is nothing but, what is that? What is my vertical force? Tell me, guys. The vertical force will be nothing but what? The weight of the fluid which is being sustained. The whatever the weight of the fluid will be there, that we have to write. Weight of the fluid. Note down what we write. Weight of the fluid, that is nothing but rho g into volume, where volume is nothing but, note down, volume above the curved surface up to the free surface. Volume above the curved surface up to the free surface. That means volume above the curved surface up to the free surface. The whole volume we have to take it. The whole particular volume we have to take, right? So what will be my volume? So you can take the volume as pi. What is the volume in this case? The volume will be, in this particular case, will be, if it is a circular one, right, a quarter circle, then pi r square by 4 into L plus length of the cylinder, let's say capital L, plus this particular volume. This, let's say this is x, right? So what we can write? That will become like a rectangular one. Tell me, guys. Imaginary liquid, imaginary whatever the surface will be there for a cylinder. So what is my volume of that? Can you please tell me? Can I say R into X into L? Check it out. Getting my point, all of you? Volume above the curved surface up to the free surface we have to take. This is the complete volume we have to take. Getting my point? Correct. Please make a note of it. Now, some of you having the confusion, you might have confusion, what the confusion you might have. You might have the confusion, sir, why we are, hello?
R into L, not perimeter into L, like which area perimeter is going
R
for
into X into L. The area, this one. This is the volume, right? Some of you might have confusion, sir, why actually, I will give some time for the writing. Let me just complete that. This is my curve surface, right? Not that important, not a single question has been asked in aerospace, but there's a nowhere written that it will not be asked. Anytime it can be asked. So let's say this is my DF force, right? And let me take the small elemental strip of that. I would say here, let's say my small area, something like this, right? So what is this? What is this? This horizontal portion. Forget about vertical line. What about the horizontal one? What should be the area? If let's say this is my area, let's say this is my DA, which is being inclined at an angle theta, for example. So what about this horizontal portion? DA sine theta. And can I say vertical portion will be DA cos theta? So this is small will be DA sine theta, DA sine theta, DA sine theta, DA sine theta. And a vertical one will be dA cos theta, dA cos theta, dA cos theta, right? So hydrostatic force, everyone know that small elemental force, if I integrate, that is nothing but dF, because dF, the vertical one will be theta, so this will be my dF cos theta, this will be my dF sin theta. I'm taking my angle from the vertical, dF cos theta. So what about this one? Oh, sorry, angle mistake is there. See, that is my force F, df force. So on this one, my df is there. This is my particular angle is there. So what about this angle? Tell me, guys. What about this angle? This will be 90 minus theta. This will be 90. So this will be theta. So if this is df, this will be df cos theta. This will be df sin theta. Getting my point? Now, so what about df? We can write p into dA into cos theta. Pressure, we know what is the pressure value. What is the particular pressure value? Let's say at any distance, the height is what? H, for example, some variable. So pressure is what? Rho gh, h into dA into cos theta, right? So what about dA cos theta? When you just take integrate all over all the domain, what is the meaning of that? What is the meaning of that? dA cos theta, dA cos theta, dA cos theta, dA cos theta. You are continuously varying, continuously varying till this free surface. What we can get it out from there? So we will be getting rho g into h bar into area which is being projected in the vertical plane. Area which is being projected in the vertical plane. Check it out. That is what we are getting, the area which is being projected because of summation of that, right? And h bar is coming because of centroidal thing. So h bar into area which is being projected in the vertical plane. Area projected in the vertical plane. If you want the proof of that. If you don't want it, directly by heart the formula. Fv component, that is nothing but the vertical component of the force, will be rho gv. V is nothing but volume above the curved surface up to the free surface. Why up to the free surface it is coming? That is what you can do here. Fv will be dfv. Once again, that we can write df into sin theta. Once again, we can write p into dA into sin theta. So once again, we can write p is what? Rho gh dA into sin theta. My dear friend, what we can write? Rho g. Now, integration of h dA sin theta. What you will be getting? From a free surface, you have the height. From a free surface, h is there, dA sin theta is there. H dA sin theta, h dA sin theta, h dA sin theta. That means, see, small area, if you just draw a small vertical area, what you will get? So this is h into dA sin theta. See that from here. H into dA sin theta. You are integrating over the all the curved surface. So you will be getting this or not? Complete area. Means complete volume. Check it out. Height into dA. You will be getting rho g into complete volume up to the free surface. Check it out. What about h dA sin theta? This is h dA. That means what? This particular component is what? dA sin theta up to the height from a free surface. This whole volume. And that we are doing integration from all the curved surface. So that is my V. And that is how we are getting V is nothing but volume above the curved surface up to the free surface. Even though the projection is not there, the surface has not been inclined till this point, right? Even though the surface is there till this point, but still we are taking whole a volume above the free surface, right? Imaginary volume we are taking, even though it is not being there. Is that clear, all of you? Because of integration. Tell me, guys. And if you don't want any headache regarding curved surface, you please remember these two formulas. That's it. One, and second formula is this one. First and second one. Yeah, please make a note of it. So we will try to see the problem regarding that. Is it done? All of you have noted down? So now we will try to see the problem that is being asked uh, in this one, in this particular slide. Now, a cylindrical gate is holding the water on the one side of the particular curved surface. On the right side, there is a no water, no water, no force, no water, no force. Simply, the curved surface is there. You try to imagine this is made up of one curved surface, and this is made up of another curved surface, and you try to take A, B, C. You try to divide it. Now, first tell me what is my forces on a AB surface. This is my forces F1, and this is my forces F2. Getting my point? So directly, what I'm doing, I'm just taking the AB surface. After getting so much of efficiency in solving the problem, you can directly take whole as a curved surface from B to C. But as of now, for understanding, we are just taking one by one. So this is my curved surface, which I'm assuming right now. And what you can understand from here, that this is my force which is being acting. This, what about my horizontal force? Rho g h bar, area which is being projected in the vertical plane. This is nothing but cylinder. Everyone know that this is nothing but cylinder. When you try to see in this way, when you try to see in this way, my dear friend, what you can understand from here? When you try to see from here, what you will see? The projected area. So 9.81 into 1000 h bar. If you just project it, you will be getting a rectangular one like this, where h is nothing but the completely for this case will be my radius is what? My radius is 1 meter. So this is my 1 meter, and the length is nothing but unit is given as 1 meter. So that is my 1 meter. That is my 1 meter. So my area will be 1 into 1. What is my h bar? H bar will be same as what we have discussed, zero point 0.5 h by 2. So when you try to calculate, what will be the answer for this? Tell me. Into 1000 into zero point 0.5, so you will be getting 4905 Newton. Remember, this is my they were asking vertical component, but I am calculating total thing in a single problem, right? Now, what about my vertical component of the forces? This will be my resolutions. That is my FH1, FV1. What about my FV1? What about my FV1? The volume above the curved surface up to the free surface. Volume above the curved surface up to the free surface. This is the volume we have to take. The red color which I have marked it. So how we can calculate? First, we can take the complete picture of that. That we can consider this like a rectangular one. 1 into 1. Width will be 1 minus of this particular quarter circle area, right? So what we can get? Pi r square by 4 into 1. That is the volume above the curved surface up to the free surface into rho g, right? So 1 minus pi by 4 into 9.81 into 1000. So when you do that, you will be getting FV1. What is the direction? In the downward directions. As when you resolve it, one here, one here. FH1, FV1, about F1. What about the curved surface AC? What about the curved surface AC, and which is being there at a height distance of 1 meter, right? As you can see, it is being there at a height of 1 meter, right? This is my curved surface which I'm considering right now. So what about my forces? This is my forces F2. So this is my FH2 and this is my FV2. Now direction will be FV2, right? So what about FH2? Same, can you say same? If I just project in the vertical plane, I once again I will be getting 1 into 1. So what I will be getting? Rho g h bar into area. Same answer, 4905. Right? Now, my dear friend, what about my vertical forces? Vertical forces will be volume above the curved surface up to the free surface. Volume above the curved surface, up to the free surface. So that is made up of two volume. One will be this one, quarter circle. Second one will be 1 into 1, width also be 1 meter. So what we can write, FV2, that is in the vertical directions, that is being in the downward directions, rho g volume. What is my volume? Quarter circle volume, pi r square, r is 1, right? And what about the width? What about the width? Pi r square by 4, that is the area into width. Width is what? 1 plus 1 into 1 into 1. So when you just calculate what you will be getting, FV1 and FV2, let me know. So pi by 4. So you got this as 17.514 kilonewton, and FV1 you are getting what? You are getting 2.105 kilonewton. Now, my dear friend, you only tell me FV2 is a larger one that is being acting like this. FV1 is a smaller one which is being acting like this. So what about the resultant vertical force? Like this. FV2 minus FV1. And what about the value? 17.15514 minus of this previous answer. So you will be getting the net force as 15.408 kilonewton, or when you multiply with the 1000, you will be getting approximate this C option. Getting my point, all of you? So from here you got the vertical force. They are asking only that thing. And when you calculate the horizontal force, you will be getting like this: FH1 plus FH2. FH1 plus, because both are acting in the same direction. See that? And when they will ask the resultant force, then what you will write? That is what F1 and F2 resultant force. What you will write? FH square plus FV square. This is what you have, FV net, FV net, and this is what you have, FH net. They ask only one question, but I have framed three questions, right? Instead of taking separate three basic question, I have just included all those three questions into the one problem. Or if you, sir, I just don't want it, basically what? Like calculating separately, I just wanted to have a single curve surface. Yes, you can take it out. Single curve surface also. Like this. Volume above the curve surface up to the free surface. So what you can write? Volume above the curve surface, that means this total volume, and that is regarding the force FV1, right? FV2, and in that we have to subtract this particular volume, this one, because in this one FV2 is acting in the downward direction. So net force will be because of this particular volume. So the net force when you calculate, rho g into V, this one. So rho g into pi r square by 2 into 1. Once again, you will be getting the same answer. Check it out. 9.81 into pi divided by 2. So you'll be getting 15,409 if you just multiply with the 1000 density. 15,409.5 Newton. Directly, shortcut. Not no shortcut, but I'm just taking the whole curve surface in a one go. No, where is the area is same. When you just take separately, my dear friend, two curve surface, Area above the curved surface, volume above the curved surface is not same. Check it out. For this one, the volume above the curved surface is total this much. Or when you just draw separately, you have this much of volume for this curved surface from here to here. But when you just take it out from here, for this one, you have volume over the curved surface till here for this curved surface. And definitely you have to subtract it, right? FV1, where is that? FV1 is what? Not a, this is not a area, this is the volume. Volume above the curved surface up to the free surface. See, how we can calculate the volume for this one? How we can calculate the volume? For a quarter cylinder, how we can able to calculate the volume? This particular volume we have to calculate. So how we can calculate? This total volume, that will give me the red color total volume. This is nothing but my one volume minus second volume. What is that? This is my quarter circle second volume. So 1 minus 2, that is my V1 for calculation of FV1. Getting my point? So that is 1 is nothing but what? 1 minus of this curved surface. Curved surface is what? What about the curved surface volume? Curved surface volume will be pi r square by 2, pi r square by 4, that is a quarter circle into width. Getting my point? All of you? Understanding or not? Now, is it done? So on a curved surface, you can focus a very, if you just want it, you can ignore this topic. Otherwise, if you have understanding, you have developed some understanding, you can solve that, right? Horizontal projected area means whatever the area which is being there, that you need to project just like this, just like this. That is my projection area. Cylinder area, see cylinder, when you see from the side, when you project it, what you will get? Rectangle or not? When you project the cylinder, when you see from here, when you project it, what you will get? Projected area as a cylinder, as a rectangle only. But what about the spherical shape? When you try to project, what you will get? When you take this sphere as an actual case, for example, when you just take it out, this one is spherical shape, and when you try to project it, what you will get? Circle you will get, right? Circle you will get. Projected area will be pi by 4 d square. But here what you will get when you project it, as you can see very clearly, when you project it, you will be getting the rectangular area only when you just project it directly. And that is what the projected area I have taken for above one and for below one. Or if you just combinedly, you can calculate FH net as complete projected area into width. So what you can calculate? Rho g, h bar is what? 1. Area will be what? Projected area 2 into 1. So anyhow, you will be getting the same answer as earlier we have got the answer. Is that clear?
Sir, sir,
Yeah. Yeah.
sir, in FH1 you wrote like rho g h bar into AV1. So vertical area, projected area will be like a 2 into diameter of
No,
the
no,
two
I have just calculated for this one.
for this one.
Hmm. Separately, I have FH1 I have written, right, as you can see here. For this one, I have written FH2. But I'm telling you directly also, you will be getting the same if you don't do separately. Now, all of you have noted down? Done for all. Same problem we can solve it here also. Force by the which we have to calculate force at B. The resultant force will be there, and just take the moment about A to be 0. This will be my H bar Cp. This is my resultant moment Fr into Y. Y will be H bar Cp plus 1 Fb into 6. So what we can write? The resultant force into H bar Cp plus 1 Fb into 5 plus 1. So through that, when you calculate, you will be getting the answer. But remember, area will be this area, which is being there in the water. Getting my point, all of you?
Sir, uh, hello.
Yes. Hello.
Sir, moment of inertia will be calculated for a 5 meter only or 6 meters for HCP, sir.
For H bar Cp, you need to have the moment of inertia for all, for a whole plate, right?
6 meter, 6 meter.
Yes.
Okay, sir.
See. No, no, no. H bar Cp you have asked, right? See here. Here, when you just calculate the see H bar Cp depending on what. Once again, whenever you have the doubt, you try to clear with the fundamental. What is the fundamental? Resultant hydrostatic force will be acting at a distance h bar Cp from a free surface, right? Free surface is there for the not the object. For which one we have the free surface? For the water, right? For the water we have the free surface, and this part of the total part which is being surrounded, right? Whatever the area we are taking as 5 into 5, right? Not 6 into 5. So why igx you will take it as something like bdq by 12, that is 5 into 5q by 12 only you will be getting. We are not bothering about this portion. That is only there for calculation of the moment. Which calculation of the moment? Only for moment about a point, that's it. Getting my point? So please make sure that once again here also you will be getting 2 by 3 of uh, into 5, that is 2 by 3 of h. So you need to be a little bit careful about that. So yeah, because for h bar Cp, the formula is coming, when you see the derivation clearly, h bar plus igx sine square theta area into h bar. So when you do the derivation, igx is coming from a wetted area of that moment of inertia. So definitely we should not take 5 into 6 q by 12. No, that is wrong, right? So here clearly you can write 5 into 6 q by 12. This is wrong. So in GATE exam, simple problem, only simple problem they can give, something like this, and they can ask, calculate the HRCP without asking FB and all, making the problem more complicated. Simply they will ask HRCP and they will test the fundamental, and this will also be there in the option. Is that clear? Now, can I move to the next segment? Is it done for all? Because in the calculation of something like this, we do Fr into y bar Cp That is nothing but df into y. Something we do that, you know. And from here, when you try to put dy, we take y from a this plate from a surface, everything from a free surface of the liquid, right? When you just go through the derivations, you know, so from a free surface only we have to do the calculations. Very good. No, no, is it done, all of you? Note down the next chapter, that is complete chapter 1 we have finished. In that sub chapters, subtopic, we have noticed fluid properties and fluid statics. Here I am taking on to the next one, that is chapter number 2, fluid kinematics. So we have fluid kinematics. One is Lagrangian descriptions. Second, we have the Eulerian descriptions, or somewhere they pronounce Eulerian descriptions. Yeah, whatever it may be. So here we have to focus our attention on the uh, how we have to understand the fluid mechanics, right? Now, have you heard the name Lagrangian descriptions or Eulerian descriptions, guys? So whenever when we talk about any engineering mechanics, or let's say the ball, when we say the ball which is moving at a speed of v, for a, basically with the acceleration of a, then we analyze the motion of the ball, right? And we are thinking about single particle, single ball, right? So that is nothing but we are focusing on our attention on a single solid particle, right? Or maybe you can think like a fluid particle. So this is nothing but your Lagrangian descriptions, right? Now, instead of, let's say, focusing on a single particle, we are focusing on a single control volume, right? On a single place. For example, in a city, you have different, you know, you have different path line is a Lagrangian. Correct, correct. So you, in a city, you have the car A, for example, you have car B, you have car C, and here you have the India Gate, for example. Every car, suppose they want to move from city A, let's suppose this whole my remaining laptop board is my city B, for example. Only this control volume is city A. Now, if you analyze the motion of single car, single car, that is Lagrangian. But if you just focus your attention on this particular place, this place, right, that every car will go through like this one, from here to here, from here to here, from here to here. There is only one way through which they can go from city A to city B, and you're focusing your camera and focusing your attention on that India Gate, then every car will pass through that. Whatever the history of the path which is being traveled by car A, car B, or car C, from which area they are coming, we are not bothering. We are focusing our focus. We are focusing our attention on this place, India Gate. That's it. So that type of analysis we call Eulerian descriptions. Make a note of it. Or that is one example. Or second example I will give about this Eulerian description as, suppose in a control volume, in a particular control volume, what you are understanding, that fluid is flowing, for example, fluid is going out, inlet section, outlet section. So what the this Eulerian description used to say, Eulerian description used to say always, you try to select first of all control volume. You always try to select one control volume. You don't focus on everywhere, you just take a control volume, right? In that control volume, right, we are focusing our attention at a particular point, let's say here, point A and point B, and we are defining whatever the velocity is there with which it is moving, whatever the acceleration with which it is moving. We are focusing totally on that particular point A in a control volume, right? So what we do here with this example, what we are actually trying to say, we are focusing our attention at a point and define velocity, displacement, and acceleration at that point. So you're not focusing the velocity, you're not calculating the velocity of a single fluid particle. You are calculating the velocity of a multiple fluid particle which is being passed through the point A. But here is steel ball, any ball. You are focusing your attention on a single fluid particle or ball. That means you are calculating one particle velocity. Suppose you are analyzing the Lagrangian description, you are applying this description to the fluid particles. Multiple fluid particles are there. Multiple fluid particle, multiple velocity. And when you do the statistical averaging, it will take much amount of time, because to calculate single fluid particle velocity will take that much of time. How many particle? Infinite time. So that is more time consuming because of large number of molecules. In case of solid, we don't have large number of molecules, right? In fluid particles, we have billions of particles which are traveling at a particular point, right, or through a particular point in a control volume, right? So sometimes we used to say this is as control mass analysis. Sorry, control mass analysis, and this we used to say control volume analysis. That's why it has been given a finite volume called control volume is defined, through which fluid is flowing in and out, and we do not keep tracking the position and velocity of a mass of a single fluid particle of a fixed quantity, right? Yes, definitely there will be some error by the Eulerian descriptions, but that error is compensated by the time which we are saving actually. Exact solution will be given by Lagrangian description. There is no doubt about that. Is it done, all of you? Can I move to the next one? Have you seen the pool ball game, like a ball pool game? Like when I just see that here, like you are basically focusing on a single ball, right, in a pool game. So what actually you're trying to doing here over here? You are trying to see the motion of individual ball, right? As we have the limited amount of ball there, not an infinite one, not a very thousand number, so we can keep tracking individual motion of a particle or ball. So that is nothing but Lagrangian descriptions. Fluid which is flowing in a pipe, fluid flowing in a pipe, that is the best example for Eulerian descriptions. We are focusing our attention on a particular control volume through which the fluid is coming and going out. And which equation will connect the dot between or gap between the Lagrangian description and Eulerian descriptions, or control mass system or control volume system? Which equation will be giving me Because see, when you apply the Newton's second law or first law for a ball, F is equal to ma, this is valid only for a control mass system, for a single fluid particle, but you are applying for a fluid particle also. This net force, as we have seen in the derivation of Navier-Stokes, we have applied even without thinking of that, without taking the permission from the Lagrangian. We have directly taken, because we have to thankful to our RTT equation, right? RTT is a bridge, correct? Exact word is a bridge between the control mass and control volume analysis, right? RTT equation, Reynolds transport equation, gives us the flexibility to use all the laws which is applicable for a single solid mechanics or engineering mechanics, that to be used for a fluid mechanics. Now, can I move to the next one? Note down the classification of the fluid flows. Only one time, one classification we will see, and then tomorrow morning we will start with the other classifications. Correct. Fluid kinematics is one of the simple topic. We have only rotation, vorticity, circulation, streamline, path line, streak line, velocity, potential function, stream function. That's it. A simple chapter. Every year we have almost 1 to 2 marks from this chapter. This year also you have one problem of 2 marks from this chapter in GATE 2023. Now, is it done, all of you? All of you have noted down study and unstudy flow definition. What is the definition? Please read out. When the properties are not changing with respect to time, but we have to fix the position. We have to fix the position. Right? What is the meaning of that? Steady and unsteady flow means the term steady implies no change of property, either velocity, temperature, at a point with the time. And opposite of steady is unsteady. Now, that means property, let me say any property, dou r by dou t at a fixed position will be zero. We have to fix the position, guys. We have to fix the position, right? And if dou r by dou t is not equal to zero, this is a steady flow. This is the unsteady flow. If I give one more practical example of this to understand this unsteady and steady flow, what could be the best example? Pipe flow problem. Let me give you the pipe flow problem. The pipe which is being connected to the tank, and here there is a reservoir and the pipe is there. Pipe of constant diameter through which the liquid is flowing out. Now try understanding. When the head of the water is constant, will the velocity will vary at a particular location? Let's say this is my fixed location. I have taken the camera and I'm noticing what is the velocity. At a time t equal to, let's say, t1, when the height is h, and when the this is open, the valve is open, the velocity v1 will be, let's say, v1, right? That particular value is x meter per second. But let's say after a certain point of time, when the level of the height is h2, what about the velocity? Of course, you might be thinking, sir, how the velocity and height is varying. Basically, it is nothing but under root of 2g h dash. As the height is decreasing, velocity will decrease, right? So what will happen? The next time t equal to t2, my velocity will be v2. So at a particular position, with respect to dou v by dou t is not equal to 0 at a fixed location 1 1. So that is nothing but this is unsteady flow, because h is varying. But once the h is fixed for all the time at a particular section, my velocity will be fixed until unless I am changing my diameter like this. Right, 1 2. So again, if height is fixed at all the time from one point, my velocity will be v1 only. That is my constant velocity. Of course here velocity will be increased, but that is my location has been changed. That is a non-uniform flow, but it is a steady flow. It is a non-uniform but a steady flow if this is fixed. But what you are observing over here, even though you are changing your location, right, at t equal to t1, at t equal to t1, you have same velocity. At t equal to t2, from here v2, here also v2. The diameter is not changing by the continuity equation, area into velocity. So if area is not changing, velocity will not change. So this is nothing but unsteady but uniform flow. Make a note of it, and once it is done, let me know. So I will be just telling you. Sorry, here it is. See, when you see uniform and non-uniform flow, any property which is not varying with the position for a fixed amount of time, when the time is fixed, if it is 0, that is a uniform flow. But no need to worry, we will start our discussion from this only, right? So those who are noting down, please make a note of it, and after noting down, you can leave for the day.
So can you explain uniform non-uniform flow again?
I will discuss tomorrow. You just focus attention on study and unstudy. That means if I have the watch, I keep on changing my time. I am observing that at time t equal to 1 second, height is h. Time t equal to 2 second, height is h2. Then what is the velocity variation at a particular fixed position 1 or either 2, right? Getting my point? Is it done? All of you have noted down? Thank you all. So tomorrow we'll make sure that these things are will be clarified, study and study with more examples, right? But those who have not understood, still I'm telling you why y bar is coming or h bar is coming instead of h bar cp. You please go through the engineering mechanics centroid derivations. Definitely you will be getting the instantly you will be getting your answer. Why h bar is coming only? Why not h bar cp? Yeah, I will upload it.